Good morning, y'all. In this video, I'm going to start on classical mechanics, explaining on classical mechanics. So this will be an introductory class on classical mechanics, the basic stuff, where it came from and how, and who are the pioneer. So everyone knows classical mechanics, right? What does it do? Sorry. What does it do? So basically in classical mechanics, it is a branch of physics, you can say. It is a branch of physics that describes the phenomena around us. So basically, if you look around your house, whenever you go outside the house or whatever, let's say you're playing football, you're watching TV, you're in motion, like you're moving, whatever that is happening around you as can be described by classical mechanics. By whatever around you, I mean the big objects and that are moving and not the motion of the objects. You can explain it by classical mechanics. But the electrical ones, you need to use electrical physics. We'll go into a bit more detail in the other video, but in this video, let's stay here. So everyone knows Newton, right? So this guy is the GOAT, you can say. Because he discovered the whole calculus, which is an important branch of mathematics and also physics. That it is a branch of mathematics, but which helps a lot. Like it helps in integral, differential, tensor calculus, and everything it helps. So he describes the most famous equation. Don't worry, I'll explain it. F equals ma. Everyone knows it that way. But here are some. The thing is that the Newton's law is written like this. No worries. It's the first video. You might be confused. You might not understand. I'll go into a bit more detail. It's just the formula that he gave. He discovered more things like gravitation law. He discovered the three the equations of motion, and he like redecorated the whole physics. He is the main, like you can say, there was no one. If there was no Newton, there wouldn't be any modern physics, because every modern physics, like quantum mechanics, particle physics, everything mostly depends on classical mechanics, or you can say Newtonian mechanics. Okay. Also, if there was no Galileo, Newton wouldn't be able to describe the equations of motion. Galileo was an important guy in physics. Mind my spelling? Galileo discovered the law of freely falling bodies. Freely falling bodies. Okay? So he like said that every object with same mass, different mass, let's say a truck and a piece of paper, would fall at the same velocity, because if it is in a vacuum, that would be true. But in this world, in our world, there is no vacuum. By vacuum, I mean there is no air resistance. In this world, we have air resistance. But in vacuum, we don't. That's why everything falls the same thing. That's what Galileo discovered. Okay? He was a really, really important guy in physics. Without him, we couldn't do anything. Also, everyone, Newtonian mechanics is the most accurate approximation, okay? But not approximation, but not the accurate value, but we can describe, we can take out from it, we discover, we do rocket stuff and a lot of stuff using this. But it's an approximation. It doesn't give accurate values, but it does help. And it's true, everything happening around us can be described by these laws. Now I'll go into a topic called rest and motion, and then I'll end the video by giving us some intuition and stuff. So rest and motion. What is rest? So every object, like this object, I'm not applying anything. I'm not doing anything. It's in rest. Why rest? Because I'm not applying any force. And it's not moving. It's not in motion. And motion is, let's say I push this pen and now it was in a moment for a slightly bit of time. But now it's in rest. Due to friction, we'll come to that later. But these two occurs by external force, and that is what Newton's first law says. Okay, sorry, family problems. Anyways, we'll come to the Newton's first law in the next videos. In today's video, I was just explaining classical mechanics and this part, but let me just end this video with explaining a bit this one in bit of detail. So it will only change its state of motion when it's applied by external force, no internal force. Okay, that is what Newton's first law says, but you won't understand it clearly until I explain it in another video. That is what rest and motion means. Okay, so basically force in physics term means an external effect that is put to an object or something to change its state of motion. I repeat again, it's an external effect applied to an object or anything to change its state of motion. Okay, that is what I have explained here throughout the whole video, and some classical mechanics and stuff. See you in the next video. Bye.